The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, May 16th, 2024. Dane is back with us. Feeling a little better, Dane? How are you today?
Yeah, doing a little better. Enough to can do this at least. A lot better than last week. But yeah, watching the volcano, got to watch John Swanson last night, and a whole bunch of stuff coming up, and just seeing how going day by day, really.
Yeah, the big story this week is obviously the anniversary of Kilauea's 100 years since the 1924 explosive eruption. So that was Don and Ben Gaddis's talk on Tuesday night after dark in the park. We will play a couple of clips of that for you guys today. We'll shuffle them around a little bit and switch up the visuals a little bit too, but just to help prompt us and really let the experts tell a story about both the human experience of what happened in 1924, as well as some of the questions we have about the science, about the explosions, why, and all of that. So we'll probably start with that and get that out of the way first, after we go through our regular weekly update, looking at what's happening in Kilauea and Maunaloa. So that's our itinerary tonight.
Yep. If anybody has any questions, go ahead and drop them in the chat, and we'll get to them at designated break. So questions about current activity would be up front, and then when we get into 24, questions about 24 and the history more.
All right, thanks, Dane. Yeah, thanks for leading that discussion in the chat. All right, so let's switch our screens around here and get ready for our weekly summary. So, all right, that goes there, and this goes here, and that goes there. And this goes off. All right. So our Hawaiian Volcano summary this week. Kilauea's earthquakes have slowed down. They have not stopped, but they are lower within this last week than the previous week and the week before that, which was the week of the crisis in the Upper East Rift Zone. So still quaking, but less than before. Looking at the map, the distribution of earthquakes is in similar locations as before, both in the South Caldera region and in that Upper East Rift Zone or Upper East Rift Connector. It's often called by both. And very few earthquakes in the Southwest Rift over here this past week. We still have the ongoing earthquakes under the south flank. That's this big cloud that exists over here, south of the rift zone. And Dipahala quakes are still ongoing as well. And here's the Kilauea piece of them on the map. But otherwise, the earthquakes are relatively fewer, and so we can see a little bit more of a pattern of their clustering here, even though they're in the same areas. So we have a new INSAR image released by the MOUNTS project. This is a satellite image. And similar to the USGS image released last week, this is showing an inflation center in the south part of the caldera. In this case, it's within the main caldera here on its southern edge within its most recent snapshot. But that zone extends south into the Kauai fault zone, bordering this Upper East Rift Zone connector. And just like last week, the supposition is that magma is filling this whole summit area, pushes against this block over here, likely injects some magma into the cracks in the Kauai, and this whole area has been rising and swelling up and rubbing against this boundary here, which causes the earthquakes. There may also be some magma moving in there, but as you can see from this ground deformation image, most of that bulging is happening within that caldera area. If we look at our tilt plot, ground tilt from the Sandhill station, that measures both that South Caldera and summit areas. The South Caldera often shows in this green signal, and the main caldera in the blue. And you can see over the last week, we have still continued slow ground inflation. That's different from the week before, where it was actually slower in that South Caldera, but still, also slower at Halemau Mountain. But still a lot slower than that first week of crisis, where it was really shooting up, tilting upwards very rapidly. So rising still, but not as fast as it was over some of the last 2 weeks. And that's true both in the South Caldera and in the summit, and both continue to inflate today. And that's Kilauea. Maunaloa is still very quiet. The earthquakes per day over the last month. You can see the high has been 6 in that summit region. So she still continues to recharge with magma recovering from the 2022 eruption. And that's our Hawaiian Volcano summary for this week. Okay, so let me switch here and we will go to our volcanic hazard summary next. And I'll try to go through our regular updates maybe a little more quickly so we can have more time for 1924. And that's partly because the story is very similar to last week. So in our volcanic hazard summary, gas is still coming from Kilauea. It's at about 60 tons per day, according to the latest USGS measurement. The stations around the summit are showing green, good air quality, although that's variable depending on the wind. So if you're in a national park, follow their advisories there. But the history on the website here is showing green across what's available, with a few of the stations having gone offline due to recent construction. We are also transitioning back into our satellite, well, it's not a satellite, into our VOG mapping, VOG measurement and prediction project, the VMAP. that puts out this animated forecast overlaid on a satellite image with a source here in Kilauea and showing the distribution of fog with the current winds. So not a lot coming out and very little impact, and this is still transitioning. So we will continue to check in on this. But for now, if you're a sensitive individual in a nearby area, then take your regular precautions. Otherwise, most people do not have much to concern themselves with. Even though the Kona winds recently have brought the smell of fog into areas where it doesn't typically go. So you might smell it even though there's really nothing volcanically going on, just a wind change. That's the volcanic hazard alert. Not much hazard out there apart from the gas. And now we'll move to our observations. And we have a photo release from the USGS that is showing to start maintenance on a summit thermal camera. So here they are. There is the tower that transmits the signal back to the observatory, solar panels, powering the batteries. I see 4 batteries in here. And you can see that all this equipment, all the wiring. And what they're doing there is calibrating it to now include a temperature scale on that camera. So if I move us to the last 24 hours from the thermal camera, you'll now notice back on the right side is this temperature scale, which is giving us a relative indication of how hot that range is. So here you're looking at maybe 40 degrees Celsius, I would imagine. So that would probably be like, you're looking at a little over 100 degrees Fahrenheit, 110, somewhere in that range. So it's hot, but it's not volcanically hot with fresh lava coming up. And when we see the scale change, then we'll have a better indication that something has actually come up, or maybe it won't be as obvious visually, depending on the view. So that's the thermal camera. There are also a couple other releases from that location looking into the crater. So let me show you those. Here is one looking down that western downdrop block, which was flooded with lava in June of last year. And within that, you see here this built up spatter cone on that southwest wall of the crater there. The lava was running off in this direction into the crater. So interesting to see a different angle there. And one more zoomed in on that crater, on that cone a little more, and seeing this whole lava lake that was being fed right over here, and that then subsided as it was robbed of its input. And so the lava flow stopped coming into it. The whole thing continued draining and cooled and contracted and left this little bay on a cooled, hardened lava floor. Okay, so a couple more images to look at, and these are a gravity survey that's ongoing. So here we see a USGS geologist. It looks like the Chain of Craters Road overlook, one of the overlooks down there, with a couple of gravimeters. These are instruments that measure very sensitively the gravity in places, and so they can do surveys over time and then see what the changes are. And the gravity will usually change in a location if you have extra magma underground or less magma underground to change the amount of material, which then is influencing the pull of gravity. So pretty cool to see them do that. They often do this every summer. And with so much action on the volcano, underground on the volcano as well, on the East Rift, it's cool to see them going out and collecting data. So that was one image. There's a couple other releases here. Let's look at them a little more closely. A couple of different instruments. These are a little fancier, it seems like the last image release we saw. So nice to see some higher tech gear, perhaps. Here you see it centered over the benchmark, looking at the rim of Kīlauea, the main caldera. So those are the images released for today. And with that, we'll turn to our monitoring signals. And we'll start with our USGS update, which does not say much new, to be honest. There's no eruption. Earthquakes are slightly above background levels, but reduced from last week. What else can I highlight in here that's really different? There's not a whole lot. We'll look at the rift zone observations. Elevated seismic activity is scattered along the East Rift Zone, with the highest density near the Hi'iaka and Pauahi crater areas. And that's basically it. Magma is pressurizing below Hawaiʻi and South Caldera, activating seismicity along the faults in the upper East Rift Zone. And at this time, it's not known what's going to happen. And that is the summary of the update, which is being issued daily, but the activity is not really changing daily anymore. Okay, looking at more monitoring signals, here's our ground tilt from Uekahuna over the last week. It's a net gain of perhaps 8 microradians or so, and that spans across a deflation-inflation event that took up the first half of the week here. So it does appear that the Hawaiʻi area is inflating, as well as that South Caldera area, just as we saw in that Sand Hill tilt, which we'll see again shortly. Over the last week, the earthquake counts don't really show much pattern. We'll zoom out to get a better view of that. But you can see in our depth time plot that there are still pulses of shallow activity of earthquakes coming in. They're just not quite as intense as before, not stacking on each other over time and space as they were a couple weeks ago, with the distribution I pointed out earlier. Here it is again. So let's just keep going past the cross section. Here is the last month of tilt. So here's that our last week is about that much. We saw the deflation inflation. And you can see that really over the last 2 weeks or so at Hawaiʻi especially, we're seeing a steeper signal on average. So perhaps the Hawaiʻi reservoir, shallow reservoir, is recently taking more of this inflation and pressurizing there. You see that a little bit here on this signal of the sandhill, but more important is this green one, since that's closer to the station, and it's still showing inflation as well. It maybe doesn't look like quite as much in this graph, but you got to remember that this scale has been massively blown out. And so if we look at just from the top to the bottom of one of these little boxes, that's 20 microradians. So here we're looking at perhaps 5 microradians as well, similar amplitude to what you see down at Hawaiʻi. And this is more what I was talking about when the earthquakes stack on each other. You can see more of the bigger picture, the big pulses. There was the one a couple weeks ago, there was the one last week, and here is what we're dealing with now. So it's still ongoing, but slower than before. And pretty steady down at the Pahala depths. All right, here is a more useful earthquake count plot, which is why we use it for our summary. It really shows a cyclicity and how it's decreasing in intensity for now, perhaps until the next batch of magma pushes us way up and forces the issue. So for the last year in earthquakes per week now, there's 2 weeks ago, there's last week, and here's this week coming in quite a bit lower, more close to the background level we're seeing prior to the ramp up at the beginning of May. So for the last 5 years, earthquakes per month, we are still adding up here, and we'll see how we end in May. We're just halfway through, so we're on track to be just as shaky as previous month here. And now the GPS. The GPS is the measurement north and south across the caldera. This Kilauea caldera in this case. And this is a 1-year plot, so we really got to zoom into the right-hand graph here. And our most recent 3 dots are showing a pretty steep rise here. And at first, it might be easy to get excited about this. Maybe it is expanding. We saw the tilt actually show Hawaiʻi inflating pretty fast. But when I look at some of the other GPS signals across the board, there's quite a few that are showing a little bit of, I'll call it noise, for lack of a better word, here in recent times. And maybe this got to do with our recent weather. It's been pretty rainy in some areas. So before making any judgment on these signals, we'll wait to see if this data cleans up, because it is a little suspicious how it's all the stations are showing a little bit of deviation all at the same time and all in the same direction. So hard to say much from this, even though it is showing up in the graph right now. And here we are at Pu'o'o. That seems to be contracting in the long term still, and also some noise, but looking like it's within the range of what we saw recently too. And also developing what we saw last week, it looked like it might have been actually rising perhaps, and we noted that there was some noise in there, and here we can see that the average is still coming down with still that same amount of noise. So that is Kilauea's monitoring signals. I thought I'd just flash up here the last week of earthquakes, how that looks compared to the last month. See that whole triangle of the Kilauea right there, south flank and Pahala, and that's compared to the last 1 year and 5 years. So this is all since 2018. If you're wondering how active a volcano is, even despite that 2018, there is a good reminder to look at that 5-year plot. Even the 1-year plot's pretty intense here. Can't even see parts of the summit in here. So very active still, even when it's slowed down for us. Okay, we can look at INSAR. This is from the Mounds project. And as I mentioned before, there's our center of inflation of South Caldera. Let's compare this to what the USGS put out last week, which is pretty similar. Their center might be slightly further south here, but this was a northern trajectory and eastern look angle. So the satellite's traveling north and looking east, whereas this one is traveling south and looking west. Right, so there's a little bit of wiggle is possible in there from these different angles. And this is compared to last week's, which was a little shifted to the south, right? That was between April 21st and May 3rd, focusing more on the southern Kauai, and recently more in the northern and south caldera regions. And you see how it's been flopping back and forth. And likewise, this was the USGS image released last week. And then one prior to that showed more of an inflation center in the southwest rift connector. So you can see over the weeks, it's just filling every little corner it can. Like it goes and fills a little bit over here, and that gets a little differs over here, fills that area. And that's why we're seeing the shifting centers of inflation over the last 6 months or so, a little further, a little bit longer than that even. So those are our monitoring signals, and we'll look at our earthquakes a little more closely here. First, colored by depth. And the red ones are shallow, the blue ones are deep. This is just the last 2 days. So let me zoom it in a little more. And so you see it's pretty slow on a day-to-day basis. I've put it on for the last 2 weeks. Now you can see that pattern a little more clearly in Kilauea there. Coming in. 2 weeks, let's zoom it out. You see Pahala, some on Maunaloa, but really not many, and background events across the island elsewhere. That's colored by depth, and let's come colored by time now. So the most recent earthquakes are happening right now in Pahala, 20 miles down, 2.0. Right, this is also the last week. And if we switch this to the largest magnitudes, the biggest one was at 3:25 this morning, 3.8, deep Pahala, 21 miles down. But as we've seen before, those can shake across the island, and we know that even some on our team felt it this morning. 3.5 as well, a little further offshore there. 3.4, deep one. All the rest are below 3. So that's the earthquakes here on the island. And to wrap up our first section here, we'll touch quickly on Maunaloa. There is a tilt for the last week, a lot of wiggles, the daily wiggles, and maybe some longer term cycles we talked about last week. Almost no data on the depth time plot, since there are very few earthquakes in the last week. And then there's more of that perhaps larger tidal signal we saw going on. Very small scale here in microradians. For the last month, mostly shallow earthquakes, not very many deep ones, maybe one very small one. And there is that very low monthly earthquake rate as we summarized at the top. Over the last year, this is a more accurate representation. We're quite low compared to this was a very deep swarm that did not result in any surface change. And for the last 5 years, this was eruption in 2022, building up to it, occurring there when earthquakes were relieved. So we're really almost at nothing compared to the buildup over the last 5 years to that recent eruption. And all was quiet on Maunaloa. Just since we did the Kilauea one, here is 1 week in Maunaloa, 1 month in Maunaloa, and 1 year in Maunaloa for comparison. Not really that exciting. If I did 5 years, would include the eruption, it would be much more exciting, but I will leave that off for now, for today. So that's the first half, Dane. If we have any questions on the current monitoring, we can take them now. Otherwise, we'll transition to our 1924 segment next. And I'll leave it to you if you want to say some thank yous.
All right.
You're realizing.
Yeah, we'll go ahead and thank everybody for tuning in today. First and foremost, we rely on viewers like you to help get this information out there. More viewers on it, the more people are getting information that might help them later in a event, which we have seen before, where lava comes into residential neighborhoods. Right now, it's in the national park, which is great, but it's still worth it to be educated on this, especially if you live on Hawaii Island with so many active volcanoes. So we appreciate viewers like you, and we do also take donations. We are a 501c3 nonprofit, and we take those over on HVERI.org/donate right there. And yeah, we'd also like to thank the Kilauea Recovery Grant and the Puna Strong funds for helping us get this information to you and maintain our operation, as well as a bunch of new things that we're doing, like the digital resilience program, which is a topic for another day. But yes, we would like to mahalo them. And I do have one question. We are restricted now a little bit with the changes over on Facebook with live streaming, but Yvonne asked us, and I can't put it on screen for you, how long after an intrusion can the surface adjust to the stress? I went to Pu'uko'ai, and the entire area by Cone Crater has now massive fresh cracks. I think it will adjust for a while, but this was huge. Oh, you're muted, Phil. There we go.
Yeah, that's a great question, Yvonne. I don't think I have a great answer for you, but we can have a little discussion perhaps. Yeah, it's all about the changing pressures on that container that the magma is in there underground, right? So if it's intruding into an area that's like, let's say it's a static crack, then it would be different than if it's intruding into a crack that's continually moving and still opening and that kind of thing. So that's where it gets a little complicated. I think if you imagine it being static, then you expect it to I would guess it would be a matter of days to weeks, perhaps, maybe into a small number of months. We saw after the 2018 eruption and lava was actually in place on the surface, how it was cooling and adjusting for days to weeks to months. So that doesn't seem like that far-fetched that it could do that also near surface underground. But I think the real wrench in there is if that crack starts opening, and if it starts opening, and then that means it's pushing on the magma slightly differently, maybe slightly less in this area and slightly more in that area, then it can actually move since it's still liquid in there. And now it gets complicated. So could some activity like an earthquake induce an eruption? That's happened in the past, right? Where you've had 1868, a big South Flank earthquake just caused the magma to squeeze out from the southwest rift because it must have been near the surface. So that's a great thing to think about out there, and it's really exciting to hear about Yvonne walking out there and seeing the earth alive under her feet there. And that's really, really awesome.
Yeah, lots of new cracks she was saying out there since the intrusion have been appearing. So yeah, really interesting. I remember after 2018, the cracks here, I don't know when what I would say that they stopped adjusting, right? On a micro level, it was like steam is still moving from different spot to different spot. There's small changes, but it still, has some variation to it. Kind of interesting, right? Just the living landscape, kind of, so to speak.
Yeah, for sure. Yeah, that's a great thing to relate as well. Your experience on Leilani, right? I think we were measuring temperatures and cracks, and it was really varying for months, wasn't it? Yeah. Maybe even up to a year.
Yeah. I mean, we kind of stopped going out there as much because we were kind of getting knowing what we would expect. But there was Rod, for instance, up in Leilani. He was continuing to monitor his cracks and stuff like that, and he still report to me like, "Oh, it moved a little bit."
Yeah. The patterns were fairly stable, right? And so we knew we weren't getting much variation for a while, though. Yeah, then we wound it down there.
All right.
Yeah.
Well, that does it for the questions for this segment. I will be getting into the historical stuff next, and maybe you have some questions about that. I know I have a bunch of questions, but I don't know if there's answers to them right now. That's what we'll talk about. Yeah.
Yeah, although I've had questions too, and I think we have a little sliver of answer, more so than we've ever had before, that came out with today's Volcano Watch, actually, following up on Don's presentation. So we'll get into that here next. So
Yeah, let's check it out.
1924, earthquakes and eruptions. And we'll start with showing a video that was put out by the USGS in commemoration of the centennial, which is narrated by Dr. Tom Jagger several years after the fact. So he's recounting the events. They've overlaid some of the images here. And let's see how, let's see here. I think this will work. Let's put this on screen and get it going.
The initiation of the explosive eruption was a series of earthquakes extending more and more toward the east point of the island of Hawaii along the chain of craters line, which ends at Kapoho, close to the shore. And in April of 1924, Kapoho was all split up with great cracks across the roads, some of them 10 feet wide, and about 75 earthquakes happened in one day. This seriously faulted the shoreline so that places along the shore sank 8 or 10 feet below sea level, and there were coconut ponds where one could swim around them after this event. This was in late April, and on May 10th at Halemaumau there began great avalanchings inward and widening of the pit. On about the 11th of May, some of the fragments falling in as avalanches began to be thrown out by steam jets. One man was killed on the 18th of May, a young fellow with a camera who had gone down to photograph after being warned by Mr. Finch of the Volcano Observatory, who had been observing the intervals were coming in Halemaumau, and he was struck by falling boulders. The lava presumably followed this line of chain of craters to the east point and flowed out under the sea. The groundwater of the island apparently got into where the red-hot hole was left by the vacating lava, and the pit above was choked by its own avalanche debris, so that a steam boiler was formed.
All right, that's the first video narrated by Dr. Jagger. And you see there that he early on identifies groundwater as a possible culprit for those explosions, creating steam. And this is what we'll explore next, actually, as Don Swanson picks this up. Something to add, Dane?
I was just going to say that the aesthetic of that video is so cool. Just the old grittiness of it and black and white footage. I just really like that whole thing.
Yeah, for sure. Well done, USGS there. Okay, so let's put on Don Swanson. Make sure I have the right one. Is this one? And he will pick up talking about the steam explosions, and we'll get into the why of the eruption here next, including our most recent questions driven by 2018. So here is Dr. Don Swanson.
Now I want to spend one slide talking about the pre-explosive activity in Lower Puna that Ben mentioned. This began following the draining of Halemaumau, and everybody has accepted the concept, including myself, that the earthquakes, ground breakage, and magma intrusion in Lower Puna were related to the draining of Halemaumau. But there's a timing problem there that no one has really thought about very much. And that is that the lava lake drained in February. The earthquakes didn't occur really until mid-April. Why was there a delay? Another question, why did the intruding magma not erupt? Why did it stay underground? We know that it erupted in that area in 2018, 1960, 1955, 1840, and around about 1790. Why didn't it come to the surface in 1924? We're stuck, we don't have any samples to look at because there was no eruption, so it's kind of hard to evaluate why this happened. And then finally, there was another problem that we haven't really addressed, and that is that the floor of Hawaiʻi apparently did not drop until when lava drained from the lake in February. Instead, it stayed put and only began to drop after the intrusion in Lower Puna had ended on April 28th. These are based on observations that were made by Oliver Emerson at the time. So why didn't the floor drop during the intrusion in Lower Puna rather than waiting until afterwards? Now, between the explosions in 1924, there was a passive steam cloud that would be rising from the crater. And this led me to prepare a model that I've shown at previous After Dark lectures. And we go from panel 1, 2, 3, 4, 5, 6. In panel 1, there's a lava lake present, fed by lava in a conduit. In panel 2, the lake has drained away. Below the water table, groundwater is now pouring into the hot conduit. The groundwater is heated by the conduit and is billowing off as steam. Panel 4 has a rock falls from the crater walls, providing a temporary dam, keeping the steam from passively boiling off. Panel 5 shows the explosion that occurs when steam pressure builds enough to blast the barrier aside. And then panel 6 shows we're back to the just passive steaming again. I was pretty happy with this model until 2018 came along. And this has led us to a lot of rethinking and a lot of non-conclusions. In 2018, there were explosions, most of which were about this size. This is about maybe a kilometer tall or a little more, topping off. There were some larger ones, to be sure, some ash, but as Ben mentioned, no large ballistic blocks were ejected up as high as the Hale parking lot. And I was able to get to the parking lot as late as June 12th of that year, so I know there were no large ballistic blocks there. But during 2018, the lava lake that had existed in Hale drained away. The conduit was emptied down below the water table. And so, you know, if the 1924 model held, why weren't we getting these steam-driven explosions in 2018? Well, after 2018, a theoretical model was proposed, and I really like this model, that suggests that after lava or magma drains the conduit, that the conduit remains too hot for a year or more before groundwater can get into the conduit to flash the steam to drive explosions. And in fact, the timing is consistent with the year that it took for a water lake to begin to form in Hale in July of 2019. So, you know, in 2018, the conduit dropped down. We didn't get anything flashing to steam, consistent with the model. But then what was going on in 1924? What accounts for the powerful explosions in 1924, the dark, ash-laden clouds? Just let it go at that. But this leads into the maybe part of this. In 2018, there's a dark eruption column, a cloud. This is May 25th. And right alongside it, there's a pure white steam cloud, not mixing with the explosion cloud. And on the 4th of July of 2018, we noticed water rushing down the wall of the collapsing crater. We didn't know it was water at the time, so we called it a black streak. But the black streak turned out to be water, as we could demonstrate readily over the next few days. So the point is that there was water present in the caldera in 2018, but it simply wasn't interacting to create the explosions. Imagine what could happen if you have a large water body distant from the conduit, a lava tube or whatever, and filled with water, and then widening of the crater breaches that conduit. Then water could pour in to the conduit and perhaps trigger an explosion like 1924. And if this had happened in 2018, we perhaps would have had a much different explosion scenario happening then. But it didn't. Could this have happened in 1924? Could there have been a lava tube filled with water or some other body that was intersected by the widening crater that caused the water to enter the hot conduit? It's just pure speculation that we don't know. In any case, though, it appears that most of the ash that was erupted in 1924 was made wet by rain, that it was not wet when it was erupted. Remember the sharp ash trickling down the creases in Stern's pants? It was dry, wasn't muddy. So it turns out that most of the 1924 explosions are consistent with the ash being wetted externally rather than being erupted as ash. There were indeed heavy rainfalls that occurred during that time, during explosions and perhaps due to cloud seeding of the kind that developed the electrical storms that Ben mentioned. But the only bad weather day really was on May 15th, and the extensive photo collection that Ben has assembled shows that most days were perfectly fine for photography. They weren't bad days, and yet the ash was still being erupted. Remember, on May 18th, the day that Truman Taylor was killed, the day was fine, no rain. So no matter how you look at it, we're forced to question our age-old or century-old and cherished notion that the explosions in 1924 were truly steam-driven, but it's kind of hard to give that up entirely. So maybe we can make a weaselly compromise and say maybe there's some sort of combination between steam-driven explosions and explosions being driven by magmatic gas exhaling explosively from the retreating magma or from magma that was re-entering the conduit system. And again, the work that Ken Berlin and Drew Downs are doing on the details of the 1924 ash may shed light on the story. But there's one interesting observation made in 1924 that makes it kind of tough to accept the conclusion that there was much magmatic gas being erupted. And that is that between explosions, frequently, people from HVO would walk around Maunaloa making observations, and they repeatedly said that they didn't have any trouble breathing. There was no sulfur dioxide in the air. It was sweet breathing. So if there was very much magmatic gas being given off in 1924, you would have expected them to have had a lot more trouble breathing. So the question remains unresolved of why the explosive activity was different in 1924 and 2018. The explosions were very different in many ways. Perhaps it was simply a question that the event size was much smaller in 1924 than 2018. Perhaps somehow this had something to do with it. Or this sort of random breaching of water-filled cavities might have been more extensive in 1924. We just don't know. The jury is out, and frankly, I think when the jury gets back in, it's going to be hung. I think we really won't understand either what happened in 1924, 1980, and why the differences are there.
All right, that was Dr. Don Swanson with a little bit of a recap of the why and the history of the theory from steam explosions to now expecting a delay, which we saw in 2018, and then what might have actually happened in 1924. So I can roll right into this Volcano Watch article here. Let's put this on the screen that was released today, which is a fresh look at Kilauea's 24 explosive deposits. And there are details in here, but to cut to the chase, to conclude the thought here, they find a surprising recent discovery is that many of the youngest layers from the 1924 deposits from the later explosions have up to 30% fresh magma. Now, this finding is not consistent with the classic interpretation of steam-driven explosions. So that's the conclusion there, right? That's the missing piece, perhaps, that we've been teased about for a while. We know that there's been a postdoc working at HVO for a while, looking at that ash and measuring properties of the crystals to figure out how much water was in the melt when it erupted. And that's where they get this conclusion that the moisture came externally, and that matches up with the reports of dry ash falling further away than around the summit area. And to get to all this, they had to go and dig through all these deposits. So there is Drew Downs, who Don mentions, and as well as Kendra Lin is the author of this article today, one of the authors. And they talk about the distribution of ash, how they had to go and collect ash, examining grains of ash, and then pulling grains of olivine minerals out of that ash. And so they still have a lot of work they can do, especially on those olivine minerals, to untangle their history. They do note that they show a large range of different magma histories of the samples of olivines they've gotten so far. So there is more to untangle there, but ultimately, here is the conclusion of that. The deposits show that 3 magma types can be distinguished in 1924 explosions. So from this, we can infer that at least 3 magma types were interacting beneath Halemaʻumaʻu prior to and during the 1924 explosion. So yeah, that's a whole bunch of new information there, right? That perhaps mixing these magmas explains why these eruptions were so explosive. So that's a big part of the story there. You got to combine that with the story of the magma draining all the way out under Kapoho in April, where all the way to the shoreline subsided, the ground sank to where the ocean came and flooded in. And for the ground to sink there, then you imagine that magma has to keep going down the rift further than that, and that would be offshore underwater. And there have been, for a while, I would call them rumors, faint references of maybe there was a submarine eruption in 1924 offshore to the east, but there has not been any evidence that's found that's conclusive that supports this. So it seems more likely it might have been an intrusion that went all the way down there, right? So you're basically making a bunch of space in a summit area. Maybe magmas are rising into this. One of those magmas, it's noted here, indicates a very high magnesium oxide content, which shows that there were 2 rare groups of grains likely from a hotter source material. So it could be that the fresh batches of magma entered Kilauea's magma system during those 1924 explosions. Right? So that could be the missing part of it there. Everything flushes out and drains away. We put it out last week how there were repeated intrusions into the East Rift and draining of the lava lake, repeated intrusions and draining of the lava lake. What made it different? Maybe that it found a path offshore underwater, and that's a much longer path, can make more space, can then drain more magma, have more collapse. If that magma had gas separated within it, then maybe that gas could have been involved in the mixing. Maybe the hot magma coming up had extra gas. There's a lot of maybes in there, but we maybe are a little step closer now that we've found up to 30% young, fresh magma in 1924. That can really reshape our entire thinking of this, right? And that's new. This is a first announcement in 100 years of this, really, right? They've said maybe there's some hints in the past, but this is the first conclusive one that I've seen here. So this is great information. Likely there'll be a major publication, and here we are getting a sneak preview.
Can I ask you a quick question on that?
Yeah.
So are they thinking, or in your interpretation, are they going with an idea that the fresher magma and the older magma mixed and that did something, or that when the fresher magma came up, it might have been accompanied by a tremendous amount of gas potentially? But as they was saying, with the low gas reports at the time, I'm just trying to square it all because it's still kind of complicated.
Yeah, I think everyone is, right. I think there is no conclusive answer to that. It's maybe both, and I think they're still in early. The first step is recognizing that there is fresh magma. Now you can run some models and say, okay, how can make this work with 3 magma kinds? What if one's more gassy? What if it's this temperature and this chemistry? What if the second one is this temperature and this chemistry? Could that result in what we see? So there's a lot of work. So we just see the very first gap in the trees out of the forest here that we've been in for 100 years with our blinders on, thinking it's only steam, right? Which is, if you go to the USGS website right now, it'll still say explosions were caused by steam. That's how new this information is. So really awesome. By the way, the talk that was given after dark in the park will be repeated on Monday, and Tuesday at the Lyman Museum down in Hilo. Right? There is admission for non-members. Right, and we do recognize that we had some streaming issues at the end of our live stream of that event, so we are also going to release a full version of that at some point soon. Okay, so that's the why, hopefully, and we don't have a conclusion there, but it's a little bit more information we had about what could have been going on and gives us new things to think about. So with that, we will then turn to some old footage here, and this is from the National Archives. There's no sound to this, and I'll just talk as it comes across here. And this is footage of 1924, reportedly on Kilauea, and it starts earlier on when there's actually lava up in the crater. So most of this is the era before these explosions. There's a little clip of the steam coming off at the end, but I thought to kind of set the scene here, it's so rare to have some of this old footage, we could put some of this National Archive footage on for you guys to see. Obviously, it's been tinted after the fact to make it look like it's a little redder, like lava. And the timing is a little off. It's a little bit time-lapse, sped up a little bit here, just because of the nature of how they were filming in that era. But you see the lava lake bubbling, gases coming out, the crust overturning right here. You see areas when the lava was draining out through particular areas on the lava lake floor. I think all we're missing is like kind of Charlie Chaplin music here in some of these cut captions. But yeah, there's a little bit more of the lava flowing out, cooling, the Hawaiian ropes in the surface. And this is what was happening in 24 between those draining of the lava lake. Right, and perhaps the draining isn't something we might catch a little bit. This is very similar to what we saw back in 2018 up in Maunaloa with this bubbling of gases off the margins. Look, there's an island in the middle of that lava lake. Lava's flowing around it. I see a lot of gas coming up as well. So pretty rare to see some of this old footage. All right, there's a nice flow. You can see a circulation pattern, and here's one of these. Looks like one of these drain back zones within that lava lake. And then here at the very end, we'll see a few shots of that steaming crater after one of these withdrawals of lava. I'm not sure exactly the date on that, but that's more or less what you would have seen that lead up, following the February withdrawal of lava, lots of steam. There it is, and then in between all those other spots as well. No big dark clouds. That's likely more of that steam billowing there. And there's our archival footage. And with that, we will turn next to the clip from Ben Gaddis that started off the After Dark in the Park presentation. And I just want to comment a little bit here that Ben Gaddis has been scanning the photos in the archives of the USGS-HVO for decades now. I can't wait until any chunk of that is released out to the public. We've released like hundreds of thousands of photographs. And we might have thousands, we don't have hundreds of thousands for sure. And in the course of all that, he's piecing together the whole history, right? He's able to tell like what goes in what order, what happened when, and he's got information that he presents here that I've actually not heard before in any other 24 presentation. So I thought there is no better replacement for Ben Gaddis than to just let him say it himself here and tell this story of the human experience and what it was like in 1924. So let's turn to Ben Gaddis, a retired judge in Hilo, obviously a volcano lover for many years, and was awarded an award from the USGS for his long-term contribution as a volunteer to the USGS. So certainly an expert too. Let's hear from Ben.
Before we go any further, let me introduce some of the most significant people that were caught up in the events of 1924. The people that were not there were the observatory founder, Thomas Jagger. He and his wife, Isabel, were on an extended trip to the East Coast. And when he learned what happened, Jagger immediately set out for home, but he arrived after things were over. Left in charge was Rui Finch. Rui was sometimes called Roy. Finch was a seismologist who'd worked for HVO for about 5 years. He was the HVO man on the spot through most of the crisis. And Finch and his wife, Margaret, who's shown here with children that she tutored, volcano children, monitored the eruption together. And she wrote nightly letters to her parents about what was happening. And her letters are frank and provide some of the best descriptions of the events that occurred. Assisting Finch was Oliver Emerson, a young graduate student on a stipend, and the canine member of the team was Teddy, Jagger's dog, and that was the entire HVO staff that were responsible for monitoring the eruption. Thomas Bowles was superintendent of the newly commissioned Hawaii National Park. He supervised a huge area with just a handful of staff, and he was anxious to promote the park and encourage visitors. And Bowles was in a tight spot, balancing his desire for more visitors with public safety concerns. In February of 1924, a lava lake drained from a pond deep in the crater of Halemaumau. In March of that year, some earthquakes occurred, but in the east rift zone, but things like that had happened before, and no one was very concerned. On April 21st, there were numerous earthquakes reported in Kapoho. The next day, things were worse. A resident living near the railroad quarry counted 238 shocks between 5 and 9 p.m. when he gave up counting and went to bed. Over the next few days, the quakes intensified, and the cracks began to open in the area. The earthquake, as you can see, left about 20 gaping cracks that extended uprift from Pu'uki'i down to the east tip of the island. This zone of cracks paralleled the East Rift Zone and was about 4 miles long and 1 mile wide. The zone acted like a hinge, dropping down 8 to 12 feet at the coastline. Scientists call a feature like this a graben. Featured here are just a few of the sites seen in 1924 by Kapoho folk. You can see the many earthquake cracks, the railroad tracks that were warped downward at the boundary of the graben, and palm trees that were on dry land a few days before were now located in a lagoon. But no lava emerged, and the earthquakes were gentle. It caused very little destruction. One reporter estimated that the total cost was about $5,000. That's 1924 dollars, of course. And contrast that with the enormous losses that occurred when 24 volcano vents opened and spilled a huge amount of lava into the lower East Rift Zone in 2018. But by April 28, 1924, Puna had stabilized and the focus moved to the summit of the volcano. Let's use this rough map drawn by Thomas Bowles at about this time to locate some of the key spots at the summit. And I've marked the spots with different colored arrows and kind of follow with me in a clockwise direction. The red arrow shows Halemaumau, which actually had a smaller circumference than shown here. And the purple arrow shows Uikahuna Bluff. And at that time, there were no structures on the bluff, and people could drive there and park and get a good view of Halemaumau. The green arrow shows the location of the volcano house, which was across the road from the main highway between Hilo and Pahala. The blue arrow shows the original location of the HVO observatory, right at the edge of the caldera where the volcano house is located today. A long winding road wound around Kilauea Iki past Tianakakoi and to an area marked by the gold arrow called Sandspit, or the airplane landing field. And then the road extended right up to the pit at Halemaumau where there was a turnaround. As things were shaking in Kapoho, harmonic tremor had appeared on the seismograph at the observatory for the first time since lava vanished from Halemaumau in February. Avalanches and dust clouds began as the floor of Halemaumau dropped away, and Park Superintendent Bowles had a problem. The next day, the steamship Samaria was due in port in Hilo on a homeward stretch of an around-the-world tour. What was he to do with the visitors? After an inspection of Halemaumau on May 9th, the superintendent declared that the room was perfectly safe. And you can see the May 9th photo with the Model T and a gentleman standing close to the edge. He decided that there'd be no problem allowing visitors there. On May 10th, the 350 passengers from the liner were escorted right up to the rim of Halemaumau. They were enveloped in swirls of what witnesses call sand. We'd probably call this tephra. And then they continued on their tour. That evening, about 12 hours after the departure of the group, the first big explosion occurred in the crater. The next morning, Finch found fragments of rock up to 100 pounds that had been blown 750 feet from the rim of the pit. The Samaria visitors timed their visit well. In early 2018, at the summit eruption, ballistic blocks of rock were also tossed into the Halemaumau parking lot, but no ballistics have been discovered that exceeded the size shown in these photographs. In 1924, gradually the ballistics ejected increased to a size that made these boulders seem tiny, and Don will talk some more about that. On May 13th, Bowles took another group out, this time to film an advertisement for a Buick automobile. There was an explosion, and boulders began falling around the group. Bowles was knocked down by a bouncing boulder and suffered severe cuts on his hands and a knee. And as rock showered around him, he related later, I began to worry whether the rock that would finally hit me would be a hot one or a cold one. 2 others were also hit by rocks, but were not seriously injured. This near-death experience caused Bowles to further restrict public access to the crater. The danger zone was reset at 2 miles. The Hilo Tribune-Herald reported that the road to the pit was walled up and absolutely no one would be allowed near the pit, or so Bowles thought. But what was going on at HVO? Well, the scientists were exhausted. Roy Finch later said that he'd had only 1 to 5 hours sleep each night for the first 10 days of the eruption. So Finch enlisted the help of volunteers to keep a 24-hour-a-day watch on the eruption. The observers recruited included his wife, Margaret, an officer from KMC, 2 newspaper reporters, and the owner of the local garage. And a routine was established. One observer would sit at the window or on the porch of the observatory with a pencil and a watch, and where the eruption cloud could be seen, another volunteer was stationed in the basement of Whitney Vault, where the seismograph was located, and you can see that with the red arrow. Numerous earthquakes caused the instrument to require constant attention as the recording pin would be jerked away from the revolving drum. From this point until the end of the crisis, volunteer observers maintained a 24-hour per day watch at the observatory, and they maintained a minute-by-minute record of what they saw. In the interest of time, we're going to skip ahead a few days. Suffice to say that the collapse and explosions at Halemaumau continued and gradually increased in intensity. On the evening of May 16th, carloads of spectators were watching the eruption from Uikuhuna Bluff. Suddenly, the entire crater turned a livid red. The volcano watchers soon beat a hasty retreat from the bluff because they could hear rocks striking the foot of the bluff below. Rain started coming down in streams, passing through clouds of ash. Soon everything in the volcano area was plastered in mud, causing tree limbs to break, ash-filled gutters to collapse from houses. And that evening, women and children were evacuated from Kilauea military camp. The next day was a visit by the 280 passengers from the cruise ship Empress of Canada. And it went off as scheduled, although not quite as planned. Despite the rockfall near Uikuhuna the previous evening, guides were allowed to drive members of the party right up to the bluff to view the eruption. One of the visitors was Major General John O'Ryan, a veteran of World War I. And he provided the New York Times with this photo, and I really wish I had a better copy. But the general described what happened. After we'd been there about a half hour, we heard a guttural sound coming from the pit, and just then smoke began to thin out. Just before the explosion, it seemed as if the pit took a deep inhalation because the little smoke that was then leaving the mouth of the pit was sucked downward. A moment later, there was a deep roar from the pit. I got the camera ready for a picture and called for my daughter to get in the car. My camera was no sooner ready than there was a great explosion. Vast volume of smoke was shot in the air. Mixed in with the smoke were thousands of tons of boulders of all sizes. These were propelled into the air apparently to a very great height, and in their descent, they came in contact with other boulders on the upward journey. The result was thousands of detonations and small explosions as these boulders came into violent contact. They struck flashes of fire so that they appeared like bursting shells. Almost immediately, the sky darkened and was filled with heavy rain clouds that were not in evidence before. Great peals of thunder boomed out, and long flashes of lightning stabbed into the sides of the mountain. Several of these seemed to descend directly into the pit, and the pit immediately answered with similar shafts of lightning. They were plainly to be seen through the heavy smoke, shooting back up at the sky as if stabbing back at the clouds. The spectators fled to the volcano house, causing a scene that the Hilo Tribune-Herald described as a traffic jam taking place at the hotel. Police were given credit for preventing a serious stampede and disaster. And on that day, HVO observers recorded three explosive episodes, 4 rockfalls, 3 electrical storms, mud rains, 150 earthquakes, 30 of which were felt. Most people with the knowledge of history of Kilauea know something about the next day, May 18th. There were about a dozen people and 3 automobiles near Halemaumau when the big explosion occurred. Margaret Finch described what happened in a letter to her parents. We drove toward the pit till we came to a place where Roy thought it would be best to stop, and we planned to walk a little nearer. I could see that Mr. Taylor and the woman in his party had the typical incredulous attitude toward the danger from the volcano, and I tried to explain to them the danger, but they couldn't see why it wasn't all right to go right to the edge. It looked quite enough. After walking toward the pit for about a quarter mile, I got nervous and wouldn't go any further, so I sat down there to wait and let them go. I waited a half hour, and I got terribly worked up, for I could see that Mr. Taylor had gone right up to the edge of the pit in spite of the warnings that he'd had. 3 other men who lived here and should have known better, had gone up too, and I was nearly frantic. Then within 3 minutes, there were 3 very strong earthquakes, and then the eruption. Enormous black clouds shot up with a tremendous roar, bearing boulders. The rocks were huge because they were slightly in advance of the cloud bearing them, and they looked very large to me, even though I was more than a mile away. They must have gone 3,000 feet in the air straight up before they stopped and started to come down. As soon as the cloud had appeared, I lost sight of the men, and I was sick of the thought at what was happening to them. The aerial photo of the area was taken a few months before the eruption. The light-colored area is Sandspit, the airplane landing field, and if you look closely, you can see planes parked on the field there. Finch and most members of his party were at the far edge of Sandspit. I put a tiny red dot over on that side to let you know where they were, and that's where they were when the big explosion occurred. A large rock weighing about 300 pounds sailed over Finch and landed behind him on the lava flow of 1921. After the blast, Finch snapped this photo, the one in the lower right-hand corner, of other spectators fleeing from the blast at 11:14 a.m. We don't know who these people were. Photographer Kenichi Maehara was at Uikuhuna Bluff on that day. Shortly after Finch snapped his picture, Maehara snapped some incredible photographs. The first probably shows the blast that injured Taylor. The second shows a secondary, but much larger explosion a few minutes later. At the airplane landing field, a downpour started with a strange roaring sound. The noise was from accretionary lapilli, pellets, that had formed as ash rained through passed through the ash cloud. And these pellets of ash were as large as a pea and came pelting down on the spectators. At the summit of Kilauea, all hell had broken loose. Static electricity blew out the fuses at the volcano house and shocked anyone that tried to touch an automobile. A huge electrical storm was underway. Lightning splintered many telephone poles along the road to Hilo. When the groups reassembled away from the blast, one person was missing, Truman Taylor. Roy Finch led a party back down to the pit to find him. They heard him calling and found him badly injured by this rock. This is the rock where Teddy is standing, and you notice they marked a cross with rocks there to mark it. And as they picked him up and tried to carry him to safety, they were pelted with stones from another blast. Taylor was taken to the volcano house and then driven to Hilo Hospital, where he died that evening. A few years ago, Don and I and others went out to the area where Taylor was struck, and we found both the block that struck Taylor and the place where he was rescued. The block that struck him is the one with the red arrow down here. Later, we returned with a park archaeologist and recovered these broken eyeglasses that you can see in the lower corner. And those were embedded in 1924 ash right next to the rock that hit Taylor. Did Taylor wear glasses? We don't know. This graph is based on the record of observations in 1924 by volunteers at the observatory. The blue arrows represent felt earthquakes. The red arrows represent explosions where rocks were thrown out. And the green arrows represent electrical storms. And what you can see, aside from the events that I've talked about, is that after May 18th, the violent activity seemed to gradually subside. But if you notice, the number of felt earthquakes radically increased. And that was a cause for great concern by Finch, and led to all kinds of public disputes about whether the summit was safe for visitors. But that's a story for another evening.
That was awesome from Ben Gaddis. New information there. I don't think I'd heard about the tree limbs snapping under the weight of the mud before. That was really cool. The details of finding the fatal boulder and the glasses is really epic there too. And one last thing, Dana, you know, when after 5 days, Marie Finch hadn't slept at all, you had to call for the community to volunteer and help collect information. That sounds a little familiar too.
Right. The interesting thing was also the electrical storms, the extent of them and how far they reached. That was surprising. I mean, I can see electrical storms up at the summit, but these things are extending miles and miles away, right? Almost to Hilo, wasn't it?
Yeah.
Some of those storms.
Yeah.
So that's wild to think that could be, you know, we could have had that almost, you know, with the situation we had over the past 6 years. We didn't go explosive, right? And that was part of the figuring out how it even goes explosive. Because I remember when the freshwater lake was in the crater, it was like, well, this could be the situation where it goes explosive. But, you know,
Yeah.
really interesting.
Don thought so. I mean, they put out a warning to people in case it wasn't the case. They weren't certain, of course. But then now they've had to rethink everything, and you know, that's awesome that they are doing so.
Right.
Yeah, and it's just the amount of rock that gets pulverized into ash and thrown into the air is what dictates your electrical storms. It's all the ash grains rubbing on each other, creating that static, and that's what drives all those electrical storms. So we heard reports of that ash cloud rising up, hitting the trade winds, going to the southwest, continuing to rise into the jet stream and flowing back east across the island. That's why it rained mud as far as Maku'u. I had to leave that clip out of this little edit, but there was, I think it was May 16th when during that first big explosion when a crater turned red, that mud fell on a railroad tracks at Maku'u, and a railroad was spinning on the tracks. They had to shut the railroad down for the day. So that shows you how far the ash was traveling, and where there's ash, then you can have your electrical storm as well. And that makes sense that the distribution was really more massive, and because they saw more of the dark clouds, more of the ash being generated in particular there. So really fascinating stuff there. It's really awesome.
100 years ago today, that, right? There's a train at Maku'u that got covered in ash such that it couldn't move. Pretty wild. You know, how much has changed since then.
Right. Yeah, the old Railroad Avenue. Yeah, and we'll look at that a little bit here too, because what we'll do next now is we transition to our special bonus for this week. And what we've done is we've restored and colorized historic photographs from 1924. Shout out to Lou, producer here backstage, did a lot of this work. And we'll just kind of.
Why don't we bring him on and let him talk about this, huh? Since he put in all this work, I can step out.
Well, yeah. Well, hold on. I'm presenting the thing here first.
Okay.
So all right, this is what we're going to basically do is go through the sequence as it's put out on a USGS site. So the sources for this are the 1924 explosive eruption site from the USGS here, which has got a lot of this information, the story, and you can see all these black and white photographs. And furthermore, coming to the bottom of the page, here's a little redone model of what Don talked about, steam-driven explosions. And here's our explosions were powered by steam right there. But coming down here to the bottom, there is a slideshow, here, an image gallery with a lot of these images that are largely a source for what we have for you guys here. That's the more numerous source, but we also have the National Park has a page as well with some additional photographs, such as this one. These are often by the same photographer. They're just in different collections potentially. And they also have an image gallery here that has these images here. So those are our sources. And what I'll do is I'll read from the captions that are given where they're available here as we show this to you guys. So, and we're going to try to recap the same sequence as Ben Gaddis just presented and just highlight some of the same images that he showed as well. And maybe after all that, we can bring him on and he can give his experience of putting this all together here. So, okay, to start off, this image from the National Park of lava draining in Hawaiʻi. This was that era, that phase before the explosions. We talked about how there were the most recent draining before the explosion was in February, but also how there were drainings in the previous year in August and June, right? So that's what that looks like. It's, yeah, some of the images you'll see they have different results a little bit, but it's just a different take. So just roll with it here. This is that sketch map of Kapahua earthquakes on the island. And what you should see here is these series of all these little lines where the cracks occurred. And there's one line of cracks on the north side of that rift over here. That's the one that was moving the most. And then there was a second one on the south side, and that was the hinge. So it was kind of dropping down more so on this north side here. And let me point out, here's a railroad to Hilo right there. Now, modern day Railroad Avenue out of that area. But there it is. And if you look a little more closely right here, right along that fault scarp at the Kula Quarry, right, they have a splay of the track here where the engine can go to collect the quarry materials. And then from there, it loops down to Kapahua Depot, right next to Kapahua Cone. And from there, it would continue going further into Puna, right? But so these are the areas that we have a photograph from the Kapahua train station. We have one from this junction right here coming up. And if you look in the background, you might see some of these cones around here, Hawaiʻi Kamahina, for example, there. So to start, Kapahua residents in April 22nd, 1924, there was a lot of agriculture happening in this area. So these may have been resident agricultural workers. What the USGS says here is that by April 22nd, the incessant earthquakes caused many people to leave the district. When Hilo reporter Belknap reached the Kapahua train station, he found a great crowd waiting for the autos that were hauling passengers out of the district. A special train was sent to within a half-mile of the station, where the crew found that the track had become twisted. Right. So what really happened here, if I can go back one slide here, is they were waiting at the train station to catch the train out, but there was a big problem with the tracks right there, and so they were having to wait to go out by road instead to get out of here. That's the residence there. Wrong way. Here is a large crack near Kauai that widened over a week. So this was a continuous road at the start. And you can see that by the first few days, it's already moved massively. But that movement continues for a couple of weeks. And over that time, the crack gets wider and wider. It's hard to pick out in the shadows. Here's the gentleman on the ground with a measuring tape, trying to measure this distance going across here, both the downdropped offset and the lateral offset too. And here are the railroad tracks at that buckled fault boundary. So looking here, here's a crack that goes this way. Right? It looks like if you look right over here behind the engine, there's a splay that goes off. That's prior to the quarry right there. And that one goes likely to Kapoho, Hawaiʻi Kamahina in the background right there. And there's what that would look like. I think Rui Finch measured the drop here to be 8 feet. And this is where the railroad tracks were suspended by, I want to say it was 200 feet. Let's see if I can find the right caption to see that accurately. Yeah, about 61 meters, 200 feet. And there's the railroad track. Also around Kapoho, that cracks continue. There's another cracked road here. And hopefully you guys are enjoying the extra color that's in here, even if it is a little artificial. Still helps us feel more connected, I think, And this is important because the reason we talk about this is so we can be better prepared for what the volcano does in the future through education here. So next we'll go to the Kapele Lagoon. This was near the eastern tip of the island. And this whole area then further sank in later years and eventually became the area of Kapoho Bay around there. And now it's been covered in 2018 as well. But what you can see is coconut trees don't start off growing in the ocean. So they were on land and the land dropped into the ocean to drown them there. That's part of that dropping sequence in April in Lower Puna. But back to Halemaumau, here is that first dust cloud. And there's the Model T person at the edge. You can see that there's collapses happening and steam coming out at that time, as Ben Gaddis pointed out. First explosive clouds. Perhaps it would have looked gray like this. You see that interesting crater floor. And one thing that's really cool to me is seeing this lava shield that exists here on the floor of the caldera. That's a result of all those lava lakes prior to 1924 spilling out and sending flows from that area over there. So that's cool to me to see that profile like that. We talk about it and see it in maps, but to see it in color is a little bit more special to me too. That first explosion, here is these fragments of that 100-pound block and where it hit on the lava, and see if I can do that to a rock. Anything that's not as strong as a rock will get even more pulverized than that. And there's the rock itself. It seemed to have hit and bounced, rolled over. And the explosions are intensifying. May 13th, we're starting to get more of that ash component here. You see how dark that looks, right? This is the darkness comes from the original image. It's slightly colored in our AI color correction here. That gives you a good idea. And that might have been the one that injured Superintendent Bowles from National Park. And here he is with his bandaged hands once again, standing, looks like in a volcano house area. It's the view looking off to the crater in the background there. A couple more explosion images enhanced here from perhaps May 16th from National Park Service. Different angles a little bit here, but see this one, pretty cool to see. There was not a whole lot before. You're seeing the top of the cloud right here as an eruption actually initiates this particular explosive phase. And then this one, you can see a different angle on how much material has gotten up and blown over and it's collapsing down here on the backside as well. See all that dark material against the horizon here. Been really intense there. This is the image that Reef Finch snapped while fleeing after that 300-pound rock flew over his head. And these are likely the people who made it out of there, and not Truman Taylor, who did not until later. From Wikahuna, here's images by the photographer from up there. You can see the tree in the foreground here. I think I've seen that tree growing here in recent years still. And zooming in, you can see all the massive movement and how turbulent this explosion is in the fine details here. Sweeping across the caldera floor, you see it looks like maybe what the general was describing, with rocks hitting each other in midair and going in random directions, and it gets a little bit of that kind of feel with some of the trails of dust through here. There's Teddy right there, and there's that boulder. That's the fatal boulder, the impact zone, or where he I'm not sure what that little arrow is. The big hole where the boulder landed right here. So the boulder landed here and bounced this way. And then he was found here, and you can see there's a cross that was pointed out as well. It goes that way in case you have a hard time seeing it like that on the ground. Some famous photographs of that big 8-ton boulder. Here it is, just a few days after the fact, when a big crater still exists. And see the photographer, the camera there today. That's one of many pictures of this boulder. That's one famous one. Here's another one. I like to see it colored as well. Another camera case there. And one final one, because this became a tourist attraction for many years. So later on, they had a sign next to it, and tourists would come, like these children in later decades there. So those are the biggest ones. Most of the boulders were smaller than that, but there were quite a few big ones closer to the edge, especially. Here is the airplane landing field, and this is notable because they would have cleared this of all these rocks beforehand so the airplanes could use the runway. So what you're seeing is what accumulated in this cleared area during that explosive phase, all these loose boulders through there, and with a plume passively degassing here in the background in between those explosions. Different view once again, more of the tephra ejected, and all the smooth stuff in between, that's all that ash. Right? So the really fine material, that's also the new stuff there. So you're getting this mixture of the boulders and the ash. And in later years, when you could visit the Hawaiian Overlook, when it was open before it fell into the crater there, you would see this ash would be what you walked over in a trail to the Hawaiian Overlook and you'd see these blocks embedded, stuck like concreted, almost, like a hardened within that ash layer on the floor. So really nice to see it there, and just a few days into it. All right, from Volcano House, a view of a group looking at one of those explosions. May 22nd was one of the bigger ones. Not the biggest, that was May 18th, that took Taylor's life. And a different view of that same scene there, a little higher capture of the ash cloud. And out of the Volcano House porch itself. So people are usually milling around in here, looking out past these bushes for the view of the explosion in the crater. But this is nice to see the shot from within the porch itself, what that looked like back then. So steam clouds in between explosions, as Don mentioned earlier on. There is one of them, very white in appearance. And another big steam cloud on May 24th. This is one of the most famous images by Tai-Sing Liu here from USGS, and yeah, really makes it more alive, I think, to see it colored in there. Really personally enjoy that, even knowing it's not quite real since it's colorized after the fact here. Still educational to me. So boulders thrown out around Hawaiian Mountain. All these big boulders were really near the edge, apart from that really big one that left that big divot that we showed, the famous one with the sign. All these other ones later fell back in the crater, but this looks like the superintendent once again, or another park employee, showing the size of one of these big boulders there. Dr. Jagger, perhaps near the same boulder, and you can see on the ground here, this is all that ash as well. And you can see that since the ash is deposited, there's these big gullies in it, where that massive rainfall must have carved down and eroded away this still fresh, loose material at the time. It's a pretty cool. And yeah, if you look at this previous one, you see that same landscape over here as well. That's what was all around, is all this ash, just about everywhere. Here is a place where Teddy pawed his way across that still wet ash and left his paw prints. Not too dissimilar to what we imagine happened in 1790 with the Hawaiian warriors who were in Kilauea's party, who were caught and left footprints in the ash as well. And them and their families and rescuers coming from downslope. This is Jagger up here, and with that cap. And there he is once again, amid the ash blocks, next to the big cracks that widened that crater. So the crater increased in diameter by 2. It was twice as wide after the fact, and it was much deeper as well. So it was 4 times its original volume after this explosive phase of eruption. And after that, you have a big crater. There continue to be rock falls, lots of earthquakes. But lava does come back into that pit once in this summertime in July. There were then going to be 7 short eruptions. This is one of 7 eruptions over the next 10 years or so. And then a volcano goes quiet until the 50s. So this was really a monumental change in how the volcano was behaving. And that's really interesting because that's another big difference from 2018 is we saw after 2018, after a big collapse, our supply rate did not go down. It's been healthy. We've had 5 eruptions, And so far, it looks like it's not stopping anytime soon, given all the earthquakes we've been having recently. So that's the sequence of images here. I'll just say include one last thing from Volcano Watch last week. It was the blast of the citric Kilauea, referring to what Jagger says here at the end. He was in New York when eruption started, and a private letter written 23 years later, he lamented, 1924 is my responsibility. My absence was a pity, the most fatal disappointment of my life. Poor Jagger that he was not able to be present for that biggest event that occurred in the last 100 years explosively, right? Kilauea here. So one last thing to show, and let's maybe bring Lou on after Dane gives us some comments here. But there is this one image of the distribution of ballistics and tephra. So the ones that were larger than 10 inches are in this red zone right in here. And you get ones that are down to 1/4 inch all the way out into the desert downwind nowadays, right? So that's a distribution. That is our slideshow. I'll pull it back to the top here, and Dane, you're on.
Yeah, I mean, it's definitely interesting photos there, and different era entirely that they lived in. I mean, it's just kind of funny to me. What was it? Roy was his name, the guy with the hand that got injured, who also happened to be in charge of safety somehow. And it's like, it took him getting injured by the thing, but he's like, oh yeah, maybe we shouldn't go right up to the edge. Good job, buddy. Getting a great safety there. At least,
yeah.
Well,
and then he set the rule, and then no one followed it, and someone got killed.
Yep. And even that the part about the wife not wanting to continue going closer to the edge and then erupting, I'm like, yep, add that to the list of why women live longer than men, because we got a lot of those.
Yeah.
But yeah, really interesting stuff. But I let Lou come in and say what this process has been like, because I actually did do this probably 4 years ago, a similar colorizing of the 1924 photos. So see what Lou has to say about it.
Well, how's it going?
Hey Lou, good job, man.
Thanks. That was an interesting project, honestly, and I have to say it's probably been one of the most interesting weeks that I've had in the last couple of years in the volcano world. Before I really break down the whole photo thing, is just the reliving through the words and the stories of everybody has been fascinating. And Tuesday night was epic. I spent, I don't know, 10 hours, I guess, rewatching everything when I was doing all the captions. And it just, you start putting yourself in people's sneakers, or their loafers, I guess, at that time, being out there. So with the photos, back in the 1920s, they were using 35 millimeter film. And one of the boulder shots, you saw one of the cameras that one of the gentlemen was holding. And that was pretty typical. They did have some smaller ones at that time, but they were all pretty big. And it was a pop the lens open for 5 to 10 seconds. So to stop while you're running away from an explosive event to get a shot, that one shot was still pretty impressive, even though that was the best I could clear it up. That's impressive to be out there and be able to do that. Some of the photos, when I look at them now, watching the slideshow, I really got a lot of appreciation for what AI does for the color enhancements. I used 2 different programs to do this, and I really couldn't tell if you were flipping back and forth between the 2 different ones. Were you?
Yeah, I did.
Some of them have more texture to them. Some of them have a little bit more just color, vibrant color, and where color shouldn't be, it makes up its own color. A few years ago, I used to colorize photos by hand, meaning that every section, piece by piece, color by color. Now it's pretty much, honestly, just a one click with some minor adjustments to it, without taking it too far and making it look like somebody painted it. Some of that's unavoidable, but they came out really good. I'm glad you guys all enjoyed them.
Yeah, one thing I noticed was interesting as I was going through it. It depends on which program and which image, really, because like some of the images have black speckles in them from the film being old. Some have black speckles in them because those are actually rocks falling through the air.
Right.
And sometimes you want to remove them, and sometimes you don't, depending on what they actually are. If they're rocks falling through the air, you want them to stay there because that's part of the picture. But the AI doesn't know that necessarily, what belongs where.
Yeah,
So
and
that's
I
why we
didn't go
do versions and compare and iterate. Yeah, that was really great.
And I didn't go in and take any of that out. I left that natural, what happened to the film, stay in the film. Unless AI took it out and I didn't catch it, and because I can't really prevent it from taking it out, but I can redo it so that it stays in there enough times, maybe 3-4 times. It kind of figures out, let's just keep giving this guy a different option. So you can see in this photo up in the upper left-hand corner, you can see some film mark in there. The boulders, like you said, some of the weird fragments throughout the ash is there, but that the quakes, there's one of the quake photos in there. I did that maybe 15 times before I found one I liked. That really struggled when it came to depth and colors, even though it's black and white. Shades of gray, there are hundreds of thousands of shades of gray that it's dealing with. That was a struggle. Some of them took 5 minutes, some of them took 30 minutes, depending on what I wanted to see. And when it comes to this, it's kind of artistic, right? It's the person that's doing it, what they feel good about.
Yeah, for sure. And I chose the ones that I liked better when I was looking at one or the other based on, what caught my eye. And some of them, you could see like, yeah, this one's got a lot less of the actual grain of the film itself. And when it cleared up, I took that one. And when it cleared it rocks, I did not take that one, so. Yeah, it really is like still, there's no one size fits all, but
no,
very powerful stuff. And hopefully it's opened everyone's imagination a little bit here, a little bit more, right? Just to see that extra dimension of color here.
If you've never tried any of the AI apps that are out there, try them out. You'd be surprised. Even a color photo. Watch what it can do to restore just a photo you probably didn't like. It's pretty amazing how it'll clear it right up tremendously.
Some of these were slightly blurry and it actually sharpened them. Sometimes it'll make them more blurry and that's not, then you throw that out, but sometimes it'll actually sharpen them. So right on. Appreciate that, Lou.
Absolutely.
Wrap it up here. And I'll wrap it up by just mentioning our community corner, where there are still some events happening in National Park. There is at Kahuku this Saturday encore of the performance Nanio Kahuku Living History Play, one-woman play on the location where the diary was written. So Lou and I hope to record this. It will not be streaming live since it's the reception. And eventually, someday, we hope to release it when we have time to do some editing, which we have not had much time recently. And then next week will be a cultural presentation on Hawaiian Ava, right? And the following day will be a Hawaiian music concert with Kainani Kahaunaele. So look for those as well coming up in May on your community events. And finally, there's still construction happening in National Park in the usual places that we won't repeat again. But if you're in a park, then plan accordingly. And that is it for today. We've gone on more than an hour and a half here. So Dane, what did you got? Wrap us up here.
Yeah, we did have one question. We can go ahead and do that. But first, I want to just thank everybody again for tuning in today. We rely on viewers like you, those likes, subscriptions, the subscribes. They definitely do help with the algorithm. So we appreciate everybody that tuned in today, especially when it's not erupting, right? When it's erupting, a lot of people will show up. But when it's not erupting, that's when you can learn something. So we appreciate you. Oh, and we shout out to the Kilauea Recovery Grant and Puna Strong one last time. We did have one question. If you want to take that on, It was. Is there a place where Taylor lost? It's a place where Taylor lost his life marked still, or does that area still exist?
It all fell into the crater in 2018. It existed into 2018, and then now it's rubble in the bottom of the crater. So I think those guys found the glasses. I want to say it was February 2018.
Right,
February
like
or
just
March,
before.
right? Yeah,
Yeah.
my good friend is the archaeologist who went out there with them, and so yeah, I remember hearing about that and being completely mind blown. Pretty amazing. Hopefully, someone can get that last piece. Were those his glasses? Who knows?
Seems likely, but yeah. All right, and I think that does it for me. Until next week.
All right. Well, thank you, Dane. Thank you to our viewers watching us live and watching us in replay. Thanks to our ASO interpreters, Rachel and Carrie. Mahalo, you guys, as always. And yeah, Lou in the back end, we already mentioned, but not to be left out here. And until next week, actually, there was one more little clip of that 24 presentation that I did not show today. We'll see that for next week and talk about some of the other aspects of 24 as we continue working through the centennial of this event here. So until next week, unless something happens, we'll be back at a regular time, 5 p.m. Hawaiian time on Thursday, on our multitude of channels now. Where are we streaming now, Dane? Give us platforms.
So we are on YouTube and Facebook still. We've continued to do those, but we've now expanded also onto X or Twitter and Instagram, as well as the newest one that we stream onto. So check us out.
Right on. Yeah. Thank you, guys. And let's get ready for our outro here. And that said, mahalo, everybody. Until next week, aloha.